Let's do some more simplifying complex fractions. So the primary way we're going to do this is to look when there's fractions inside of another fraction. That's what we mean by complex fractions. And we're going to multiply top and bottom by the least common denominator. So in this case, the LCD is just x. So I'm going to multiply the top of the fraction by x over 1 and the bottom of the fraction by x over 1. But we're going to be distributing it to every term in the top and the bottom. So we're multiplying by x to all 4 terms in this fraction. So let's see what we get. 1 times x, or x times 1, is just x. And then, maybe I should write this out a little better. So it's 1 times x for the first one. The next one is going to be 1 over x times x over 1. Well, the whole reason we did this is so that the denominator would cancel. In the bottom, I get 1 times x, then minus 1 over x times x over 1. So I'm just putting this over 1 when it's a fraction, just to help me line it up so that it's clear like what cancels. So what I get then, 1 times x is x. And then over here, the x is canceled, so we're just left with 1. 1 times x is x, and now it's minus 1. And this is fully simplified. I can't cancel the x's or the 1's because there's addition and subtraction here. These aren't the same factor. So we're done, except we need those domain restrictions always. So we need to think about what could x not equal. Now, in this equation, we couldn't have x equal to 1, but since that's part of the function, like we don't have to specify that. But we need to go back to the beginning and look and see, well, x cannot be 0 because that would make 0 in the bottom of a fraction. And so that's the domain restriction. So when we're typing this, make sure you're putting parentheses around the top and the bottom, and then put comma, and it's that exclamation point that means not equal to 0. All right, let's try the next one. Now this one's a little different. There's where we could still use the LCD method, but what I'm seeing is that it's just one fraction divided by another fraction. So I can just write this out as x over x minus 4 divided by 3 over 2. And you know what? I'm already thinking I want to factor that, so I'm going to factor it. 2 times x minus 4. All right, as soon as I see something that wants to factor, at least at this point, I just want to factor it. So get that done, because we're going to need that anyway. To divide one fraction divided by another, all you do is flip the second fraction. So if you see it in this form, you can always just multiply by the reciprocal. Notice this previous one wasn't in that form, right? This wasn't a single fraction in the bottom or a single fraction in the top, but this one is a little different. So it's easier this way, I think. So times, so we're gonna switch from dividing by a fraction to multiplying by the reciprocal. And then see what reduces. So right away, I'm seeing the x minus 4's cancel. So what that means is in the top, what's left is 2 times x. And in the bottom, what's left is just 3. So this is our answer, but again, we need those domain restrictions. Oh, and I want to save room because I want to show it the other way too, just so we can see the LCD method. So what's our domain restriction? So if you look at the original problem, we couldn't have x equal 4. And if we set 2x minus 8 equal to 0, that's also an x can't equal 4, right? And you can see that in the factored form even better, that in both of these, the restriction is that x can't equal 4. And so that's our answer. So that's the multiply by the reciprocal option. But let's try it the LCD method. Just so we can compare so that you can make an informed decision about which you want to look at, which you want to multiply by. So I'm going to multiply by 2x minus 8, which, well, I'm going to put it in factored form. Because the LCD is 2 times x minus 4, because that would incorporate both the x minus 4 and the 2x minus 8. So that's what I'm going to multiply both top and bottom by. So let's do it. Original problem is x over x minus 4 over 3 times 2x minus 8. So I'm multiplying top and bottom by 2 times x minus 4. And you can put it over 1 if that helps you line it up. 2 times x minus 4 over 1. Now on the bottom, that completely cancels because 2x minus 4 is the same as 2x minus 8. I need to scooch up here. And on the top, it's just the x minus 4s that cancel. And after doing this, it should be that everything, all of the fractions inside of other fractions go away. So on the top, I just have a 2 and an x left. And on the bottom, I just have a 3 left. Oh, look, same answer. And same principle where we still have to look at the original problem or what canceled and say, oh yeah, I canceled a 4, so we can't have x equal 4. So actually, you know, it's not that this was that much harder, but sometimes if I see fraction divided by another fraction, I just multiply by the reciprocal, but the LCD method certainly still works too. But in a situation like this next example, I'm going to multiply by the LCD because I don't want to worry about getting common denominators on the top and bottom. So in this case, the LCD, I'm seeing a 3 and a 2 and an x. All right, that I need all 3 of those pieces, the 3, a 2, and an x involved. I don't need like 2 x's, well, I shouldn't say x squared. If I multiply everything by 6x, that should get rid of all the denominators. So that's what I'm going to do. Multiply by 6x over 1, multiply by 6x over 1, but we have to remember it's all 4 terms that are going to get multiplied. So let's do it. If I multiply 5, and I'm writing it out, 5 times 6x plus x over 3 times 6x over 1, 4 over x times 6x over 1 minus 1 over 2x times 6x over 1. All right, if in doubt, write it out. It rhymes, so it must be true. Let's see what we do. So the first multiplication, 5 times 6x, well, that's just 30x. Easy. This next one, we got to look for what cancels. 3 goes into 6 2 times. So all together, multiplying this, I would get plus 2x squared. Okay. In the bottom, now the x's cancel in this term, so we get 24. And in this term, the x's cancel, and 2 goes into 6 3 times. So it looks like I'm just left with minus 3. Hopefully you see that. Okay, let's do it. So now, in the top of the fraction, we always want to leave these factored. WebWork wants us to factor everything. I'm seeing the GCF of the top is 2x. So then what would be left is 15 plus x. And of course, you can always multiply that out if you want to, check. In the bottom, 24 minus 3 is just 21. And 2 doesn't go into 21, so this is final answer, but we need some domain restrictions. So let's see what happened. The original problem, we couldn't have x equals 0 because that would be dividing by 0. And there was nothing else at any other point that we canceled. So it's just x cannot equal 0 for our domain restriction. Nice. All right, last one. Our LCD We have all these x's. For the least common denominator, we pick the largest power of x that's in a single denominator. So x cubed, multiplying everything by x cubed will get rid of every single fraction. That's the goal. So multiplying by x cubed over 1 on the top and the bottom. But of course, gotta remember that it gets distributed to every term in the fraction. So let's see what we get. So I have 6 over x cubed times x cubed over 1. I'm just gonna write it out. If you, if you're at the point where you don't need this step anymore, that's okay. But, not everyone gets to that point. So I wanna write it out. 4 over x squared times x cubed over 1. All right, so got it all written out. Now we see what cancels. In the first fractions, the x cubes go away, so what's gonna be left is just 6. In the second fraction, x cubed divided by x squared is just x to the first power. So this will be minus 2x. In the bottom, x cubed divided by x is x squared. So it's like this just becomes a 2. So that's 3x squared. And then down here, x squared divided by x cubed is just going to be x to the first power. So plus 4x. So by multiplying by x cubed, we've got rid of every denominator, but the ones that weren't to the third power just have whatever leftover x's. Things we need to do. First, I need to factor, because both the top and the bottom have a greatest common factor that can come out. In the top, I also don't like this negative leading coefficient. So I'm going to factor out a negative 2, and then that would be x minus 3 left. And if you need convincing, right, multiply it out. So it'd be negative 2x plus 6. It doesn't have to be in that order, but that, I don't know. I like the way that looks a little better than the other way. On the bottom, the GCF is just x. So x times, and then it's 3x plus 4. Now this is one of those that in web work, you're gonna have to type a lot of parentheses. So for typing, it would be parenthesis negative 2, parenthesis x minus 3, and then like a double parenthesis, divided by parenthesis x, parenthesis 3x plus 4, and then double parenthesis. And then comma, and we need what can x not equal. So if we look at the original problem, all these, if x were 0, that would be undefined because you can't divide by 0. And that's what canceled out as we were working through the problem. So that's our domain restriction.